Hello, my name is Max, and I will be doing a presentation about sentiment analysis in topic modeling. The problem statement is BERT and DistilBERT appropriate sentiment analysis? Is LDA appropriate for topic modeling? With a huge number of reviews that an enterprise can receive in a day, rapidly identifying its sentiment and its topic is an advantage. Therefore, in this presentation, I will show you how to decide and how to apply machine learning models to solve this problem. To identify the sentiment of a review, I will use these three models, LSTM, BERT, and DistilBERT. To identify the topic of a review, I use the LDA model. The dataset used contains more than 800,000 lines, each line with a positive and a negative review of a company. The reviews are from Glassdoor, but they were collected from Kaggle. To reproduce this study, you will need these Python libraries. Attention that some libraries require some additional downloads, such as stopwords. This project was developed in 4 notebooks. They are numbered from 1 to 4. Information about the dataset and the exploratory data analysis can be found on the first notebook. First, we need to do some pre-process and clean the data. Each line of our table has a negative and a positive review. However, what we need is a table that has only one review per line and a column specifying if the review is positive or negative. This can be easily done using the function melt from pandas. After, we need to treat the missing values. Here, I decided to drop it considering the low proportion of missing values. I also substitute the special character by blank space and dropped the lines with only punctuations. At the end, I had more than 1.5 million observations, with half of them being positive and another half being negative. When working with text, it is interesting to see how many words each review has. For instance, here the shortest review have only one word and the longest one had almost 32,000 words. Moreover, it is interesting to notice that if you choose a max length for each review of 60, you will already consider more than 95% of our observation. And if we compare the length of positive and negative reviews, we can see that usually the positive reviews are shorter than the negative ones. Also, it is a good idea to see which words are most frequent. To do that, I used word cloud. But before, we need to do some pre-processing, such transforming every word to lowercase, remove punctuation, remove stopwords, and remove some words that are not relevant to our study in specific. With these word clouds, we can see that when giving positive reviews, people talk more about people and benefits. On the other hand, with negative reviews, it's common to cite the management of the company. Information about the model LSTM, BERT, and DistilBERT are on Jupyter Notebook number 2. Information about LDA model are on Jupyter Notebook number 3. First of all, I separate 20% of the data for test and another 20% for validation. Moreover, for the sentiment analysis model, I used 60 as a maximum length for the reviews. The baseline model was a neural network with a LSTM hidden layer. This model has the advantage of being simple to implement and fast to train. However, it does not capture all the relationship among words in a sentence. This model only considers that the current word is influenced solely by the preceding words. Hence, this model may have poor performance. Before applying this model, you need to do some pre-processing. You must pay attention that you need to transform each word in a number. And to do that, you need to create a dictionary. Also, you must create two additional keys for in your dictionary, one for padding and another for unknown words. What is more, you need to save this dictionary so you can use this model in production. You will create this dictionary using only the training set. And if you encounter a new word in the validation or in the test set, don't worry, they will be mapped as unknown. This is the model. One embedding layer and one LSTM layer with 32 units. The activation function of the output layer is sigmoid, the loss function is the binary cross entropy, and the optimizer is Adam. As you can see, this model has 6.5 million parameters. The BERT model is a general-purpose language model. It can be used for several tasks related to natural language processing. Differently from LSTM, BERT considers the impact of every word on every other word. A huge advantage of this model is that we can find a trained version of it in Hugging Face. Therefore, we can use a transfer lane. On the other hand, the disadvantage is that even with a transfer lane, it takes a long time to train. And moreover, it requires a considerable processing power, and preferably with a GPU with a large VRAM. As I said, Hugging Face already has a version of this model trained. So to pre-process the data, all you need to do is to use the correct function from the transformer library. Here, BERT tokenizer, and the model that we used was BERT base uncased. The BERT model has almost 110 million parameters, but using transfer learning, we will train only 24,000 related to the new denser layer and the output layer that I created. Well, the output activation function, the loss function, and the optimizer are all the same that I used on the previous LSTM model. The DistilBERT is just a simplified version of the BERT model. It has all the advantages of BERT with less disadvantages. Unfortunately, it still takes some time to train, and you better be using a good GPU to train it. The pre-processing is the same as BERT. The only thing that you need to pay attention for is to change the function in the transformer. On the BERT model, this line was different. All the rest was the same. Here, with the DistilBERT, we need to use the DistilBERT tokenizer, and the argument here is DistilBERT based uncased. The model code is also practically the same as BERT. The only difference is the function from the transformer library, that here is this one with this argument. And here you can see that the number of trainable parameters is the same as the BERT model. However, the number of parameters of the DistilBERT only is 66 million parameter and not 110 million. Because of this model is much faster to train it. For topic modeling, I used LDA. This is an unsupervised learning model. Therefore, we cannot choose the topics. We can only choose the numbers of different topics. Because of this, some disadvantages are that not all words returned as topics have meaning. Moreover, if you choose too many topics, they may overlap. On the other hand, this model is simple, fast, and it does not require much computational power. From all this pre-processing, you must take special care with removing words that are not relevant for the specific problem that you want to solve. For instance, the word bank may be relevant as a topic to legal documents, but it has no meaning for the reviews we are analyzing. Another point to take in consideration is that LDA needs a vector that counts the number of times a word appears in a document, or you can use TF-IDF vectorization. Also, when you use TF-IDF, remember that you must fit only on the training set, and that you also need to save this model to apply it on other data sets. This is the code needed to train the model and to get the topics. The model will only return the words that represents a topic. It is you who need to interpret them and come with topics that they represent. For example, the topic 0, the relevant words is or, pay, salary, work, and benefits. So you can name this category as compensation and benefits. Well, these are the results for the sentiment analysis model. As you can see, the performance of all the three models are similar. The LSTM was a little better with an accuracy of 96%. Moreover, it's important to notice that if we added some regularization or dropout layers on this model, we could properly train more than 3 epochs without overfitting. We could also get a better performance on BERT and DistilBERT if you had trained them for more epochs. However, we must take in account the training time. For instance, to train the LSTM model, it took only 21 minutes. However, to train the BERT model, it took almost half a day. And to train the DistilBERT, it took 6 hours. Okay. If you consider that the performance metrics of the LSTM already is good enough for using it, there is no reason to invest so much time on training these more complex models. For the LDA model, initially, I wanted to separate the reviews in 6 topics as Glassdoor. However, when plotting the intertopic distance map, we can see that topics 4 and 5 are overlapping. I tried modeling with 5 topics. However, even so, the topics 4 and 5 were still overlapping. Hence, I used only 4 topics, and I could come with this uh, a nice plot where none of the topics are overlapping. Finally, on Jupyter Notebook number 4, you can find 2 ways to apply the models built on the previous steps. First, I apply the LSTM and the LDA for a dataset with a lot of reviews and filtered a company. Here we can see that the positive points of this company is that the work-life balance. On the other hand, the senior management is not so good in that company. Another analysis that I did is that I come up with a new review and use the LSTM and LDA models. The review that I used was, it is good, but it's also bad. I don't know. Maybe they could train better the management. The LSTM model returned the sentence as being negative, as expected. However, the LDA, for some reason categorized it as compensation and benefits. Therefore, the LDA model did not work as expected because the point of this review was the bad management and not the compensation or benefits. Uh, Thank you very much.